Okay, so today we're doing lesson 1.5. And the book just calls us equations. Now again, I'm going to change this. I'm going to change it from what the book says. Let's call it Intro to Equations. Because we're going to get into equations in depth. You've had some experience with equations in the past. But today we're just going to intro some vocabulary, make sure that you all are on the same page, understand what you're being asked to do, and so on and so forth. So today's date is the 7th of October. Okay, so I'm going to do a lot of writing words and highlighting them, making sure that you understand you need to know these vocab words. Okay? All right, so let's start with, I'm going to get bored, so I'm going to do a lot of different color today because it's just kind of, like I said, boring notes. So let's talk about what is an open sentence. Now, anytime we're in a math class, when we hear the word sentence, we're talking about a mathematical equation is a sentence. Okay, so the mathematical equivalent of an English sentence is something with complete a beginning, a middle, and end punctuation. Okay? Our punctuation is an equal sign. So anytime you hear that word sentence in a math class, it's talking about equals. Okay? So let's talk about an open sentence first, and then we'll do equations. We'll have all sorts of different things. Now, when they talk about an expression, that's like in English class, that's a phrase. It's just a piece, nothing you can do with it other than simplify it, or if somebody told you what the variables equal, plug numbers in and solve it. It stands by itself, and you can't really do much to it. Okay, there's no what is x equals, because there's no equals involved. All right, and we talked about those. So an open sentence is a mathematical statement and that means it does contain the equal sign, but it also contains algebraic expressions. So when I say algebraic expressions, when you hear that word algebra, what are you realizing is part of this open sentence? What makes algebra algebra? Variables, okay? So algebraic expressions are expressions that contain variables. You've dealt with several of those in homework already. And symbols. Oops, sorry, symbols, not symbol-y. Symbols. So an open sentence, the key for this one, I'm going to highlight him. We'll do him in a different color. Is the idea of variables. In order to have an open sentence, it must be an equation, and it must contain variables, okay? So then let's go to what is an equation. Okay, what is an equation? An equation is a mathematical sentence that contains an equal sign. Although maybe if I learned how to spell. So as soon as we throw in an equal sign, we have an equation. So again, key for this guy is going to be that equal sign. Okay? All right. Next comes the word solution. Now, so far, I don't think I'm throwing anything unusual to you guys. I think these words should be fairly familiar. Oops, sorry, wrong thing. That was supposed to be him. So what is a solution? A solution is a value for a variable that makes the mathematical sentence true. And I'm going to, in pink, highlight that word true. Okay. So we spend the most amount of time in algebra having these mathematical sentences, statements, that are considered open sentences because there's variables involved, but we solve them to figure out what that solution or solutions are. How we begin the process is to give you a group of numbers for you to choose from to see if any of them are the solution, okay? That group is called a replacement set. So that's our next word. I told you this was boring. Boring but necessary, right? You're like, no. So a replacement set is a set of numbers that can replace the variable a set of numbers that can replace the variable to check. Don't you love it when you say one thing and you write a completely different word? Check for a solution. Okay. So I'm going to highlight that phrase. Come here, you. Replace the variable. Okay. All right. Everybody good? Now, let's use that word set. Come in here. So a set is a collection of, and I'm going to use numbers because we're talking about math. Now it could be objects, but we're going to work with numbers. A collection of numbers shown inside of braces. And remember, braces is a grouping symbol that looks kind of like a forehead, a nose, and a chin. So it's kind of curvy, pointy, curvy. And I'm just going to tell you right now, I'm good on one direction, and I stink at the other direction. They never look like, they are not mirror images when I draw mine. But what I need is them not to be squared off, because that's brackets. So they look something like this. Okay? Well, we'll see. They're okay. Both of them are okay. So I'm going to highlight here the word braces and then the symbol of them in pink. So braces. So if you remember back to the very first assignment you guys had, the collaborative notes on the real number system, and you were supposed to watch some videos and write some stuff, there was something on there that said set notation. That's writing with braces. Often what happens is that we can present a group of replacement numbers as a set of numbers. We can deal with solutions as a set of answers. We're going to be talking tomorrow about domain and range, and we write them, a domain as a set of numbers and range as a set of numbers. So this notation shows up a lot. And if it doesn't show up a lot this year, it shows up a ton in Algebra 2. Very, very important. So we're just going to, again, laying the groundwork for what we're covering. And then I'm just going to throw out all the words so we all know what we're talking about. Oops. You need to change. So next is what is an element. And you guys will be learning about that in science class. We talk about, did you have tests on elements already? Well, an element is a member of a set. So each number inside of the braces is called an element. So I'm going to highlight in pink 2 words on this one. Member set. Okay. And then for a short period of time, this will be the last one. Let's see. Let's do something. I've used up like all my colors. We'll go dark. Solution set. So the solution set is all values from the replacement set that make the open sentence, so the sentence that contains variables, true. Okay, so here's the difference between what you might be working on tonight versus what you've done in the past when you've solved equations for a variable. Tonight, we're going to give you in set notation, these are the numbers you have to try out. There may be one solution, there may be 2 solutions, there may be all of them are solutions, there may be no solution, okay? But you got to test them all. When you were solving equations last year trying to figure out what the variable equaled, your replacement set was all real numbers. So you solved it, and you could have the answer be from the wide world of numbers that exist. Okay? So that's the difference. Your solution set, or your replacement set, when you're solving a regular equation, is infinite. When you're doing it tonight, you have a very finite, very small group of numbers to choose from. Okay? And though I know you could say, I already know what the answer is, you still got to go through the practice. Okay? All right. That's that for right now. We're going to go to the odd page, and we're going to go ahead and we're going to do some practice problems. So this is your odd page, and so here's your first set of directions. Find the solution set of the equation. Nico, you got to write it down. 2q plus 5 equals 13 if the replacement set is the set containing 2, 3, 4, 5, 6. So what I'm going to do is give you a suggestion as to how I would set this problem up. And this is going to be kind of a motto that we're going to use in several different situations. And what I would suggest that you use is a table. And here's what your table would look like. It's going to have headings. These numbers 2, 3, 4, 5, 6 are going to be the choices we're going to plug in for Q. So that's going to be the first title of our chart is Q. Then we're going to put the equation in so we know what we're plugging the numbers into. And this one can be large so that you can show your work. This could be you do this in your head. You could check it. This I'm going to do maybe, actually I'm going to make it a little bit larger because I want to do, yep, that's a Q. And then we're going to say, is it true or false? If it's true, it's a solution. If it's false, then it's not a solution. So what's going to go down the Q column are your replacement numbers. So this is a good habit to get into when you're asked to solve it with the replacement set. If you're asked to solve, then you can use the math that we've talked about in the past, and we'll review that as well. So how this works in the middle column is that I'm going to substitute in, one at a time, a number from the replacement set. So I get 2 times 2 is 4. 4 plus 5 is 9. And the question is, does 9 equal 13? And the answer is no, so it's false. So 2 is not a solution to this particular problem. So then we're going to try 3. Oh, sorry, that's not supposed to be there. It's supposed to be a 2. And then in parentheses would go the 3. So 2 times 3 is 6, 6 plus 5 is 11, and then we have 11 equals 13. Is that true or false? So that would be a false. So next we're going to try 4. And we have 8 plus 5 is 13, and is 13 equal to 13? So finally we have a true, okay, but we got to test them all. Sometimes there is more than one correct answer. So we're going to test 5. Oh, sorry. There we go. So we get 10 plus 5 is 15. Does 15 equal 13? No, it doesn't, so that's false. And then last but not least, we're going to try 6. Sorry, 5. No, this is just some of the problems are like this. So we have 12 plus 5 is 17. Does 17 equal 13? No. So that's false. So what you would say is the solution set is, and then you would take whatever numbers were true and you would put them in set notation. So 4 made it true, and that would be your answer. Now, they gave you 5 choices to look at. You're going to have I think the first problems that you're going to be doing on homework, I haven't written your homework up yet. Let's see, what did I have you start at? 11. So you're going to do, you will have 5 choices. So you are going to practice this on about 4 problems. Okay? So that's one thing that you're going to see on homework. Okay? And then you are going to be doing questions like this. Solve. So this one says 6 plus the quantity 5 squared minus 5 divided by 2 equals P. So in this particular problem, they're not giving you a solution or replacement set to choose from. Your job is to just do math that you know so that you can figure out the value of P. Basically, it's saying you have the gamut of all numbers to choose from here. But instead of guessing and plugging it in, let's let the math help us figure it out. So what can I use that we've talked about to help me solve this particular problem? Yeah, order of operations. GEMDAS. Thank you. So that's what we're going to do on this one. Now, I'm going to use my symmetric property because I want my P to be on the other side because that's what I'm solving for. And I have 6 plus 5 squared minus 5 divided by 2. So we follow order of operations, and that says take care of what's inside the grouping symbols. We have exponents, so I have 25 replaces the 5 squared. And then I take care of what's in the grouping symbols. 25, take away 5 is 20, so I substitute that in. I have a division problem, takes priority over addition. 20 divided by 2 is 10. And I get P equals 16. Okay? So this one, because I'm solving, I would write my answer P equals number. You could write it in the solution set notation. That says the same thing, that P is equal to 16. That's the solution for this one. Okay. Now, this is really hard for me to agree to, but I'm going to at this point, because from when we talk about subsequent lessons, this is not acceptable to do what you're about to do here. But for this purpose, we're going to go ahead and solve out a problem. So we've got, this direction says solve. Here, I'm going to erase this. Solve each equation. That's a terrible solve, so let's have me try that again. Solve each equation. And so number 3, we've got 7 minus the quantity, 4 squared, minus 10, minus 10 plus n equals 10. So in this problem, again, we've got a lot of math we can do. We can use the order of operations, but our ultimate job is what can n equal? Now, again, this is uncomfortable for me because I'm a stickler for details. However, for this particular assignment, this is what we're going to do. We're going to get this equation simplified as much as we possibly can. But we don't necessarily need to isolate the variable. So inside the parentheses, 4 squared is 16. So I substitute in its value. I take care of what's inside the parentheses. 16 take away 10 is 6. 7 take away 6 is 1. So I have 1 plus n equals 10. And now here's where you look and say, what value could I substitute in for n so that I would have a true statement? 9. So if we replace n with 9, we would get 10 equals 10. So our answer would be n equals 9. Okay. Now, me personally, if we were solving equations, I'd make you do inverse operations to get the n completely alone. But for tonight, we're okay stopping at this point. Yes? At this point, I want you just to do it this way because I want you to look for some patterns that are going to occur. And so number 4, in particular, has an interesting pattern. So this one has n times the quantity, 3 plus 2, plus 6, equals 5n plus the quantity, 10 minus 3. So this one changes because n shows up 2 places, right? And that's going to be kind of strange because now I'm going to have to figure out one number that's going to replace the n so that both sides have the same value. That's going to be trickier. So here's what we look for. We're going to distribute, and we get 3n, or actually, let's be smart about it. We don't need to distribute. Let's take care of what's in the parentheses. So I have n times 1, hello English. 3 plus 2 is 5, plus 6, equals, and then 5n and 10 take away 3 is 7. And then this, I can use the commutative property of multiplication. So I have 5n plus 6 equals 5n plus 7. And what I want you to look at is what's strange about what we have at this point of simplifying. Pardon me? Okay, we do. Well, that's an equation. They're going to have equal sign. But what do you notice is kind of interesting about where we're at, Joey?
The 6 and the 7 are different.
Okay, we have 6 and 7 are different. What's the same? So my question is, if I plug in 1 for n, what does the left side equal? 11. But I have to plug in 1 for n on the other side, right? What does that side equal? 12. Can 11 equal 12? No. Because those values with the end are the same, the only place that we can look at is this. Can 6 equal 7? And the answer is 6 will never equal 7. So guess what number I can replace n with and get something that's true? 0 would give me 6 equals 7. So I can't replace n with 0. What number can I replace n with to make that sentence true? Is there any number? That's right. And that is the answer to this problem, is that, let's see what's right here. The value of n cannot make a true solution. So we would write the answer one of two ways. In words, no solution, because there's no value of n. Uh-oh, sound off. No solution. There's no number that would replace n and make the left side equal to the right side. It's impossible. Or we can use this symbol with a slash. That means no solution. Okay? Notice the way that the slash is, it's diagonal. Okay? That means it's impossible. Nothing. Okay. So then let's try this next one. And the directions on this one, again, we're back to just the word solve. And this is our equation. 2 times 5 minus 8, that quantity times the quantity 3h plus 6 equals, wow, brackets, braces, the quantity 2h plus h, close the parentheses, plus 6, I said braces, I meant parentheses, close the brackets, times 2. Woo! Look at that one. That's amazing looking. All right, so let's do what we know to do, which is let's simplify this as best as we can. So in this grouping symbol, I see some multiplication. So I'm going to do that first. 2 times 5 is 10, minus 8. And then I have a 3h plus 6. I can't simplify because of the variable. On this side, in the parentheses, I have 2h plus h. So it gives me a total of 3h's plus 6. And then I have the times 2. So on the left side, I can solve 10 take away 8 is 2. And then we have the parentheses 3h plus 6. On this side, I can actually distribute. So I get 2 times 3h is 6h. And 2 times 6 is 12. So this side I'm going to distribute, and I get 6h plus 12. And on this side, I get 6h plus 12. Okay, what's unusual about that guy? The two sides are exactly the same, right? So what could I replace h with to make a true sentence? Okay, is 1 the only choice? If I put in 1, I get 6 plus 12 is 18, and I get 6 plus 12 is 18. Is 1 only going to work, Patrick? Okay, I could put 0 in, right? And I get 12 equals 12. Lainey? Exactly. So I'm going to write a little statement here. Since any value for h gives a true solution, and I'm going to put in parentheses, both sides of the equation are identical. Oh, identical. So that's the uniqueness of this one. Since any value for h gives a true solution, all real numbers, that means every single number you've ever studied, are solutions. because you're putting the same number in on both sides on the same exact expression to get the same exact answer. Okay? So how do we write the answer? We could say, we have a couple different ways. We can say all real numbers. So that's one way to write it. There is a symbol that is kind of like a cursive R. Or we have the word identity. What property did we just write? 6x plus 12 equals 6x plus 12. Johnny, you remember? He says, I'll remember as soon as I flip my page over to my property names. It isn't symmetric. Patrick? It's not transitive. Nico? It's the reflexive property. Remember, the reflexive property is what's on the left side is identical to what's on the right side. So this is an example of reflexive. Now, I could see, Johnny, where you would come up with, Johnny Ray, excuse me, where you would come up with symmetric, because I could swap the sides and I get exactly the same thing. But with symmetric, we're actually having two different looks to the sides and then swap it around. Like when I had P equals P, and then I rewrote the, using symmetric property, P equals. Okay, so this is really explicitly a reflexive property. So let's go back to our first page, our note page, and let's write down our last word, and that's that word identity. Okay, and so identity is an equation that is true for every value of the variable. And again, let's highlight that every value in pink. Okay, so that's how we can write that answer. So this is what you got to kind of watch out for, is that you may have some things going on. All right, I have one more example. So the last example is a word problem.
I do not know. You can pitch because I have no one.
You may. So one of the things I noticed on your quiz is that you guys had to do that 4-step problem-solving plan, and a lot of you forgot the first step, which is to what's your unknown, define it. So that's, we need to make sure that we're in the habit of practicing that. Yes, ma'am. Nope, this is it. This is our last example. So we've got Mr. H pays $10 each month for movies delivered by mail. This is how I used to do Netflix. He can also rent movies in the store for $1.50 each. Write and solve an equation to find the total amount he spends this month if he rents 3 movies from the store. So what some people will do is start launching in trying to solve the problem. But you missed the part of the directions that would say you need to write an equation and solve the equation. So what we're going to do is come up with an equation, and then we'll use substitution for the value that they give us that we're going to write a variable in, and then we'll be able to write the problem. So what we're going to do is come up with actual two variables. Can I solve a two-variable equation? If I have two unknowns? And the answer is it depends on the situation. If I don't have enough information, no. If I have enough information, yes. So here's what we're going to do. We're going to create two variables. What do you think C will stand for?
Cost.
Yeah. What cost? Of the movies? Nope. Not just of the movies. What's the C going to stand for?
Cost per month.
Yeah, this is going to be the total cost per month. Or total cost per month with 3 movies. Okay, and then we need another variable to represent that number 3. What does 3 represent? Okay, so the number of rented movies. Okay, what would my equation look like if C is the total cost per month with the 3 movies and M is going to be the number of rented movies? How are we going to write our equation? Brandon?
10 plus 150 equals C.
Okay, so I'm going to put the C first because that's actually what I'm trying to solve for. Okay, so C equals, and then tell me again.
10 plus 150 C equals M? So you want to flip it.
C equals 10 plus,
$1.50.
and then the M. Okay? It doesn't matter how many movies he rents, or if he doesn't, or gets delivered to his house, or if he gets none delivered, he still pays $10 a month. Okay? But in addition, he can go to the store and get as many movies as he wants. $4.50 for each one. Okay. So that's your original equation. That's how this whole problem process starts. So we've got variables described. That's 1 out of 4 points. We've translated an equation of the situation. That's 1 out of 4 points. Now we need to solve it. What piece of information did we give that's not shown up in our problem yet? Michael? The 3 movies. So our problem now with substitution becomes C equals 10 plus $1.50 times 3. And then we just kind of solve it out from here. So we get C equals 10 plus $4.50. And when we add that up, we get C equals $14.50. So the answer is it will cost Mr. H $14.50 if he rents 3 movies this month. Okay, so our goal is to start writing our answers to word problems as a sentence so that the $14.50 has a context. Okay?